we've been effectively leading this project called Speed, and Speed is based upon the Bloodhound Supersonic Car Challenge. And so what we've been doing today is really the culmination of a schools-based project where teams of school students compete with each other to redesign that car and try to make it go faster, and of course race against each other. And they've been using online high-performance computing resource from the University of Bristol, using real computational fluid dynamics analysis to try and go faster.
So the children were able to play with a variety of parameters that affect the geometry of the car and the running of the car. So things like what angle should the car be at, what droop angle should the nose have, at what time should they launch the rocket. And they've been trying to understand, I guess, what we've been trying to understand, which is which are the important parameters that drive the performance and ultimately the top speed of the car.
Well, if the wheels are too thick, then it would cause too much friction on the ground, which would slow the car down.
And create a drag. But if they were too thin, then it would cut into the ground, making the car slow down.
I've been focusing on when to start the rocket off. It's between 14 and 15 I got it going at the high speed.
Or if you had the gap between the car and the ground too big, then all the air would just go underneath and it could maybe cause the car to lift off the ground.
And then we looked at the speed of sound and the history of it because we thought that'd be interesting part of the whole presentation.
I was amazed to see, these are children 11 to 14 years old talking about quite complex aerodynamic concepts and talking about high performance computing and talking about CFD, things that I wouldn't have had a clue about when I was their age. So it's amazing to see now what school children are exposed to and what the Bloodhound project can bring to a school science lesson or maths lesson. So what the schools would get back from their simulations is a combination of, they get pressure plots showing actually what the flow looks like over the car, so the pressure distribution over the car itself. Then they'd get acceleration against time graphs, velocity against time graphs, where they can see how the acceleration is varying with time and the velocity is varying with time, which then obviously shows you your peak speed. So it wasn't just this single number they get back, they get a whole set of data that they can use to analyse and make decisions about how to progress their design.
As a school, we're very much trying really hard to promote STEM activities and the interest in engineering. So we've made it almost a priority to sort of to up the level of understanding with our students and the opportunities out there. And it's been lovely through this project to see the girls equally as enthusiastic as the boys.